Hey, Algebra 2. My voice is getting better, as you may be able to tell. We're going to talk through Lesson 18 today, which is overcoming a second obstacle in factoring. What if there is a remainder? Okay, that would be the part of division in factoring. So let's just talk about this rational number, and let's write it as a mixed number. There's a few ways we can talk about mixed numbers and how to separate it out. If I separated 13 into 12 plus 1 and kept it over 4, I can do 12 over 4 plus 1 over 4, which gives me 3 and 1/4. How I always learned how to write improper fractions as mixed fractions was to actually do division. 4 goes into 13 3 times. There's one remainder, so your answer is 3 and 1/4. If you remember, your remainder goes over, and you have your answer. So let's try a more appropriate Algebra 2 problem for our first example. We're actually going to tackle this problem two different ways. So looking at this first one, it says find the quotient by factoring the numerator. We can factor this numerator. It actually factors into x plus 1 and x plus 2. At that point, because we have x plus 2 in the numerator and the denominator, we can cancel them out, giving us an answer of x plus 1. I need to point out at this point, because that's in our denominator, we need to make sure that everyone's aware x cannot equal -2 in this problem. Okay, if we put in a -2 for x, we get 0, which is a no-no. We cannot have 0 in a denominator. This is the one we're going to tackle in 3 different ways. So be patient. We're going to try this 3 ways, and you can think about your favorite one to use. So again, here we need to make sure we know that x cannot equal -2, because if you put -2 into the denominator, you would get 0, which is a no-no, as we are aware. Okay, we already know the fact that x squared plus 3x plus 2 over x plus 2 equals x plus 1, because we did that in the previous example. That was in part A. So how can we use that information to find x squared plus 3x plus 5 over x plus 2? Since we know that 3 plus 2 is 5, let's use that information to our advantage. So I'm just rewriting it. Sort of magic. We already know that this is x plus 1, x plus 2. Cool. Now I can cancel that out and write my answer. Oops. Put parentheses around that, and we have our answer. Our remainder is 3 in this problem. Okay, if we remember, when we had the problem at the beginning, 13 over 4, we broke it down into 12 over 4 plus 1 over 4. And there we knew our answer was 3 1/4. Our remainder in that problem was 1. Okay, let's try another method. When we first learned division in polynomials, one of the methods we learned was tabular method. So we're actually going to try that now to figure out our remainder. Get everything set up. So we have x squared, 3x, and 5, which is the same as 2 plus 3. Draw our arrows up. And 2 and x. Okay, so 2 works, giving me a 1 up here and an x there. So if this is an x and we're trying to get to 3x, we need a 2x here, which gives me an x up there. And then this last blank, make sure we did it all right. We're good. So our answer is, oops, that should not be an x. X plus 1 plus, this is left over, 3 over x plus 2. This being sort of the key to what we need to figure out. 5 was in the problem. I can't use 5 because 5 is not a factor of 2. The only factors of 2 are 2 and 1. So I have to use 2, which means this 3 is my remainder. Okay, there's another example in example 2. So if that's a little bit confusing, let's try it again in a little bit. This method is long division, and this is actually how I learned how to do these type of problems, which does not make it right. It just makes it a different way. Some of you don't like the long division method, and that's fine. You can do the tabular, or you can, the first method we did is called just by inspection. So I'm going to put an x here, and I've got x squared plus 2x. Subtract everything out, x left over, plus 5. I can only do a plus 1, so I get x plus 2. Do some subtraction, and I have 3 as my remainder. So that's how I know how to write plus 3 over x plus 2. I like this method personally just because it's very similar to what we did in the beginning, 13 over 4. Do a division problem. 3 times 4 is 12, and I have a remainder of 1. So, okay, I have my remainder. Because that's how my mind works, that's what I prefer, but you can pick the method that you like and go for it. Let's try another one. So first, let's find the quotient by factoring the numerator. I have x minus 2 times x squared plus 2x plus 4 over x minus 2. So I have my answer, x squared plus 2x plus 4. Okay, and let's try another one. When we did example 1, we worked on this type of problem with 3 different methods. Method 1 sort of taught us to have a puzzle, play a puzzle with it, see if we can make it into something that we can easily factor. This makes sense to me because we know how to factor x cubed minus 8, and that's what we factored up here. So in essence, this part of the problem we know what to do with. Okay, this is going to be our leftovers. So let's do it. We're going to have x squared plus 2x plus 4, which is this part of the problem, correct? And then our remainder is going to be 4 over x minus 2. So if that makes sense to you, if you like that method, it seems to be pretty quick. Let's try the other 2 methods. Okay, the second thing we did was the reverse tabular method. let's see, we had x cubed, 0x squared, 0x, and negative 4. So here I have x minus 2. We're trying to find the top here. So let's see if we can figure this out. Oh, forgot the arrows. Arrows. Okay, let's look at this one. I'm going to start in the upper left-hand corner, up here, and see what we need to write. So I believe if I do x squared, and I multiply across the row and the column, I get x cubed here, and negative 2x squared. Work my way up here. To get 0, I would need a positive 2x squared, and to get that, I would need 2x. So 2x times x is 2x squared. 2x times negative 2 is negative 2x. To get that to be 0, I would need a positive 2x, which would mean I need a 2 up here, because 2 times x is 2x, and 2 times negative 2 is negative 4. I'm going to correct a mistake that I made right here without backing up. The original problem, nope, that's right. Hold on. Did I make a mistake somewhere else? Oh, silly me. Okay, let's erase, because I don't want to. This is right. Oh, good. This is wrong. Okay, 2 times negative 2 is negative 4x. I wish I were still in black ink. To get that up here, I would need a negative 4. I don't know if I can still erase this. Oh, I can. And erase this, because it is still wrong. Goodness. To get rid of the negative 4, because it's 0, I would need a positive 4x, which means I would need 4 up here, which would give me negative 8 here. Now, negative 4 is the problem, so that would be negative 8 plus 4. The remainder is 4. Okay? Let's try the last method, which is long division, which is technically my favorite. Let's see. We're dividing x cubed, 0x squared, 0x minus 4. X squared gives us x cubed minus 2x squared. I'm subtracting that. Gives me 2x squared plus 0x. Multiply by 2x. 2x squared minus 4x. Subtract. I get positive 4x plus 4. Let's see. Multiply through 4x minus 8. Subtract, and I have positive 4 as the remainder. We got the remainder 3 ways. Very exciting. Okay, there are 10 example problems that you can do. 10. So I'm going to work through each of them. You may work through each of them with me, or work through 1 or 2, move to the next set. So there's groups of 3. The first 3 will be finding each quotient by inspection. Okay, so let's work on this one by inspection. This first one looks pretty simple. I can change this to x plus 1 plus 3 over x plus 1. So my remainder is 3. So my answer is 1 plus 3 over x plus 1. this next one, I have 2x minus 7 over x minus 3. I need to play some games to figure this one out. I know I can go 2x minus 6 minus 1 is the same. I know I'm trying to get to an x minus 3. So if I factor out a 2, I'm there, which is very exciting. So I'm going to separate this 2x minus 3 over x minus 3 minus 1 over x minus 3. Those cancel out. I'm left with 2 minus 1 over x minus 3. Very exciting. Okay, this last one. Let's see what I can figure out. I really want to change this numerator into the difference of squares, and I know one of them is going to be an x plus 4. So I think I need 16 up there. So x squared minus 16 minus 5. That would allow me to go x plus 4, x minus 4, minus 5. This is over x plus 4, x plus 4. I'm left with x minus 4 minus 5 over x plus 4. Starting to enjoy this method. Let's move on. The next three, I'm going to point out 1, 2, 3, 4. Numbers 4 through 6 are going to be reverse tabular method, and then 7 through 9 will be long division, and then number 10 is a special one. So you can spend as much time as you feel necessary on all the rest of these example problems, because there are a lot. If you want to figure out the tabular method a little bit better, then please spend a little bit more time on numbers 4 through 6. If you don't like that method, maybe you can practice those with another method to solve, like use those and practice the inspection a little bit more, etc. But there are a lot more example problems that you can choose to follow or choose to skip. Okay, reverse tabular method. Let's try a few. I've been interrupted a few times, so I'm not sure if I've told you guys this. This is probably my least favorite method, but it's okay. I will do it for y'all. Aha. So again, I'm going to start up in this square up here. So to get x squared, I would need an x. X times x is x squared. X times negative 8 is negative 8x. I need a 4 there, so I'm going to add, add 12, because 12 minus 8 is 4. Now, to get a 12 there, I need to multiply here by 12. 12 times x is 12x. 12 times 8 is 96. Negative 96. So 10, which is what our problem is, would be negative 96 plus 106. That right there is our remainder. So our quotient is x plus 12 plus 106 over x minus 8. Let's try the next one. I can already tell number 6 I'm going to need a new slide for. Okay, x cubed, negative x squared, 3x, and negative 1, x plus 3. Up here I need x squared, multiply through, x cubed, 3x squared. To get negative x squared, I would need a negative 4x squared. Up here, negative 4x, because negative 4x times x is negative 4x squared. Negative 12x. And then to get 3, I would need a positive 15x, which would mean I need 15 up here. 15 times 3 is 45. Negative 1 would be 45 minus 46. That's a 46. So our answer is x squared minus 4x plus 15 minus 46 over x plus 3. Cool? All right, let's do the next one on a new slide. Okay, so this is number 6. X squared minus 2x minus 19 over x minus 1. X squared, negative 2x, and negative 19 over x minus 1. So here I have an x. So I have negative x in that box, which means I need another negative x over here to get negative 2x. So a negative 1, which would give me a 1. Negative 19 would be 1 minus 20. So my answer is x minus 1 minus 20 over x minus 1. Cool? All right, moving on. All right, find each quotient using long division, my personal favorite. Number 7. Like I said, you can listen to or work through as many of these as you're comfortable. If you need more practice, keep going. If you feel like you got it, you got it. So I'm just doing long division, which we've already done in the past. You can check me for mistakes, which is always fun. So negative x minus 6x would be negative 7x. That's usually where I make my mistakes. But knowing is half the battle. 7 times 6 is 42. So subtract it. Oh, I should have done that. That would give me a positive 42, 17. So my answer is x minus 7 plus 17 over x plus 6. Okay, number 8. X to the 4th, 0, x to the 3rd, x squared, 0x, 12. X plus 2. Oh, I'm so sorry. I did not leave enough room. So let's put it up here. X to the 3rd power. 2 x to the 3rd power. Subtract. I need a negative 2x squared, because this is a 3. Negative 2x to the 3rd power minus 4x squared. 8, negative 8 plus 4 would be negative 4. So this would be minus 4x. Negative 4x squared minus 4x. Subtract, and I have 4x plus 12. So plus 4. I think I've made a mistake. Let's see. So that would give me x to the 4th plus 2x to the 3rd. Subtract, I've got negative. So minus 2x. Minus 2x minus 4x. Subtract, so that would give me plus, which would be negative 4. That's right. So negative 4. So minus 4x being minus 4x squared. There we go. That should be an 8. So this should be an 8. So this should be an 8. Thanks for playing along. So we have 8x plus 16. Subtract, and I have a negative 4. So my answer is x to the cubed. I can't find my good pen, so I'm having issues. X cubed minus 2x squared minus 4x plus 8 over, or no, plus 4 over x plus 2, because my remainder here is 4. Negative. Phew. Okay, we're going to do number 9 on the next page. Number 9 is 2x minus 5 into 4x cubed plus 0x squared plus 5x minus 8. 2x squared here. That gives me 4x cubed minus 10. Subtract, I have 10x squared plus 5x. This would be a plus 5x. 10x squared minus 25x, yikes. Subtract, which makes that positive, so that gives me 30x minus 8. So that would be plus 15, 30x, 15 times 5, 75. So negative 8 plus 75. Because it's minus. So my answer is 2x squared plus 5x plus 15 plus 67 over 2x minus 5. Phew. Okay, last one. This is the one I said you should pay attention to. Okay, number 10. Rewrite the numerator in the form x minus h squared plus k by completing the square. Then find the quotient. Okay, well, let's do it. I have x squared plus 4x. I take 4 over 2, which is 2, and square it. So add 4 here, minus 9, and subtract 4 there to make sure all is balanced in the world. That first one is a perfect square, x plus 2 quantity squared minus 13 over x plus 2 over x plus 2. Those cancel out. I'm left with x plus 2 minus 13 over x plus 2. That's actually sort of simple if you can not lose anything. All right, mental math exercises. They're on the next page, and they're actually really good for fluency. All the numerators factor nicely so that there are no remainders. This exercise would be fun if we wanted to go ahead and time it. We could, it just could be a lot of fun. It's a good idea to maybe practice through these and get some answers. It'd be fun to see like how many you can get done in 2 minutes, because you should be able to whip through them pretty quick. So I might save this for a fun exercise, a timed exercise in the future. So if you want to write things down and maybe practice on your own, it would be pretty awesome. If you want the answers, you can ask me tomorrow. Okay, in closing, we did a lot today. We did a lot of problems using 3 different methods. And I don't need you to use all 3 methods. You should pick one that works for you and run with it. I like the long division. It's my favorite. It may be my favorite because it's how I was taught a long time ago. But if you like the reverse tabular method, that's great. Inspection can be fun, so you choose.